Okay, so we are going to let this tank of water represent the water in the ocean. It's been sitting for a while, so it's all the same temperature. But we're going to put this side of the tank to represent the equator, and on the other side of the tank, we're going to make that represent the polar ice caps, north or south, it doesn't matter. So what I'm going to do now is I'm going to take some dye, just some red dye, and place it into the water just so we can understand that there's not really much going on there. Of course, the dye does sink to the bottom of the tank because it's slightly denser than the surrounding water, but for the most part, we can see that it's not really moving all that much. Now, I'm going to take a heat source to represent the heat of the sun um, as it heats up the water near the equator. So I'm just using some boiling water, and I'll put it under the tank here so that we can see the effects of the heat on the water in the tank. So let me just adjust this, and it's looking a little foggy here, so I'm going to clean up the fog a little bit so we can see. But what we're going to do is we're going to observe the motion of the dye so you can see. And you can see right here that there is some motion occurring. As the water heats up, it becomes less dense than the surrounding water. And so you can start to see that the dye is now being pushed up, is floating towards the top. Now it's not just the dye itself; it is actually being carried by the water. And so as the water heats up, the surrounding water, which is less dense, I'm sorry, which is more dense than it, starts to push it up. Now, of course, uh, water can't just rise up by itself. The surrounding water actually gets pulled in behind it, which therefore pulls in more of the dye. And so you can see it just rises all the way up to the top of the surface. So we would consider that the ocean surface. Now, it won't just keep on rising. It can't rise past the surface. So what it's going to do is start to move away from the heat source in whatever direction it wants, which is why you see it floating along the surface away from the equator to what would be the most obvious place, which is the polar ice cap. So we're going to use a block of ice to represent the polar ice caps. It's really cold over there, and you could probably predict what's going to happen to this water as it reaches the polar ice caps and gets cold again. But I'm going to use some blue dye to represent that colder water. You'll start to see that colder water, which is denser, start to sink. But there's something else going on here. This is ocean water after all, and so it's salt water. And so some of the water there begins to freeze, but the salt can't freeze. And so the salt gets left behind in the surrounding water, making it actually saltier, thereby making the water even denser. So we've got two factors going on here: the coldness of the water and the saltiness of the water makes this water sink fairly quickly. And you can see it sinks all the way to the bottom until it reaches the bottom of the tank, which I guess we can consider the ocean floor. And because you can't make a pile of cold water, it just travels along the floor away from that source of sinking water. And of course, where's it going to go? Toward the equator. So again, that is that colder, saltier water heading away from the poles back to the equator. You can see that as it reaches the equator, it's starting to warm up a little bit. So you're going to start to see, there it goes, the colder water start to rise because it's no longer the cold water. Remember, that's just the color doesn't really make a difference. It's just tracking the movement of the water itself. I'll just put a little more dye in here to show you what's happening. Again, that sank really fast because the water is so cold on that side of the tank. And you can see how it just sort of gets carried over to the equator side, the warmer side, again, because all that cold water is just piling up and pushing along the ocean floor. Where it rises, comes across on the surface, reaches the cold poles and then sinks back down again. So it kind of travels in this circuit. Now, the scientific name for this circuit is called the thermohaline current. Thermo meaning temperature because it has to do with the hotness and the coldness, and haline related to saline, which means the saltiness of it, because remember, the polar ice caps end up making that water saltier. So it's this uh, colder, saltier water traveling along the ocean floor, which gets warmed up and then rises to the surface where the warmer water travels along the surface toward the poles. So it's this constant churning around, but we give it a cute nickname. We call it the Global Conveyor Belt.